Lesson 9.1 is quadratic models. I would pause the video and write down these notes. So quadratic functions are polynomial functions with degree 2, which means the highest power is a 2. So they're functions of the form f of x equals ax squared plus bx plus c, where a, b, and c are all real numbers, and a is not 0. b and c can be 0 just as long as a is not 0. We call a, b, and c the parameters of this function. The graph of a quadratic function is a parabola or parabolic shape. The vertex is the maximum or minimum point, so that turning point. The zeros or the x-intercepts are where the graph crosses the x-axis, so where your y or f of x is equal to 0. So you can solve this by factoring if the quadratic factor is completing the square, or quadratic formula. So if you have a, b, and c, the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Your y-intercepts are where the graph crosses the y-axis, where your x-coordinate is equal to 0. And then every parabola has an axis of symmetry, which is the line of symmetry of the quadratic graph, and it goes right down the middle. So it goes through the x-coordinate of the vertex. If your x-intercepts are x sub 1 and x sub 2, then the axis of symmetry is x equals the average of your two x-intercepts. It's right in the middle. So given the function f of x is equal to negative 0.5x squared plus 7.5x minus 18, go ahead and pull that up on your graphing calculator and use your graphing calculator to sketch a graph of f. Make sure you label the coordinates for any axis intercepts, so your x and y intercepts, and the vertex or any vertices. Once you've done that, find the domain and range of the function and the equation for the axis of symmetry. So I graphed this on my graphing calculator and I just copied this sketch over. So I found that it had a y-intercept at 0, 18. It had x-intercepts at 3, 0 and 12, 0, and it had a vertex at 7.5, 10.125. And I found all those just by using the intersect or the 0 function on the graphing calculator and the maximum function on the graphing calculator. So domain, for a parabola, the domain is always all real numbers. The range is the maximum value here at the vertex, 10.125, and then everything less than that, so y is less than or equal to 10.125. And then the axis of symmetry is a vertical line that goes through the x-coordinate of the vertex, which you can find by finding the average between the two x-intercepts. So 3 plus 12 over 2 is 15 over 2, or 7.5, so the axis of symmetry is x equals 7.5. So here are 6 quadratic functions, a through f, and we want to fill in this table here. So the value of parameter a, b, c, and then you can use the graphing calculator if you need to find the y-intercept and decide whether or not this has a maximum or a minimum point. Keeping in mind that the general function for a quadratic is f of x equals ax squared plus bx plus c. So go ahead and pause the video and fill out this table, and then answer questions 2 and 3 based on that table. So here are all the tables. So for function b, you have a equals 1, b equals 4, c equals 3. You have a y-intercept of 0, 3, and a minimum. For function c, you have a equals negative 1, b equals 1, and c equals 2, a y-intercept of 0, 2, and a maximum. For function d, you have a equals 2, b equals negative 8, c equals negative 10, a y-intercept of 0, negative 10, and a minimum. Function e, you have a equals negative 2, b equals 3, c equals 9, a y-intercept of 0, 9, and a maximum. And then function e, you have a equals 4, b equals negative 8, c equals 3, a y-intercept of 3, and a minimum. So for number 2, it says, how does the sign of a determine whether or not a vertex is a minimum or a maximum? So if a is positive, like functions a, b, d, and f, you ended up with a minimum. That's because the function opens up, and so therefore the vertex is going to be the minimum point. If a is negative, like functions c and e, that means the function opens down. It's been reflected across the x-axis, so therefore the vertex is a maximum point. So if a is positive, you have a minimum. If a is negative, you have a maximum. For number 3, it says, what is the connection between the value of c and the y-intercept? Well, if I plug in 0 for x, anything that has an x in it is going to go away, so all you're left with is c. So c is always your y-coordinate of your y-intercept. So So this has been an introduction to quadratic functions.